Hello everyone, Gaza Mutkash, and I welcome you all to this session on data cleaning and pre-processing. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding encoding categorical variables. Then we'll look at the different methods of encoding and we'll be implementing them as well. So far till the previous session, we have discussed type conversion and normalization and how to handle null values and duplicate values as well. So guys, let's switch to the Jupyter screen. So guys, over here we are in the Jupyter screen, right? So first of all, it's important to understand what encoding is all about. So encoding is a technique that is used to convert categorical data into continuous data. All right. So why do we need to encode categorical variables? Suppose we are working on some machine learning or deep learning algorithm. This is where we may come across n number of different categorical features. Now, any ML or DL model cannot be trained on data that is string or object in nature. So this is where it becomes imperative to convert it from, let's say, string or object to integers or floats. So to implement this, we perform encoding. All right. So encoding, I'll write this down. Encoding is a technique used to convert categorical data into continuous data. Alright, so encoding categorical variables is essential because most machine learning models can only interpret numerical inputs. Alright, so we have to encode them so that model can be trained. When we are talking about machine learning model training, essentially we are talking about, let's say, performing n number of mathematical operations, and these mathematical operations, they do require numerical data. Now this numerical data can be in integer or it can be in float. Alright, so in pandas, let's say there are several common encoding techniques to transform categorical features into numerical format, each suited to different use cases. So guys, let's have a look at different encoding techniques. So the first one is called label encoding. Alright, the second one is referred to as one hot encoding, or also known as dummy variable creation. The third one is referred to as ordinal encoding. So these are the different encoding methods that we shall be discussing. All right. So we'll discuss them one by one, but I need to have some, let's say, dummy data to work with. So over here, what I'm going to do, first of all, I need to import pandas, and I'll also be importing numpy. All right. So guys, as you can see, we have imported numpy and pandas over here. Now moving forward, I'll be creating a data frame. Let's assume that the number of rows that I want is 50. All right, df is pd dot data frame. All right, over here I've created a data frame. Now I'll be adding categorical columns. So let's assume I'm adding columns such as gender, then city, means we do have some employee data. So gender, city, then education. All right, and then let's say maybe job. All right, so these are different types of categorical features. Now besides this, I can pass department as well. So let's generate synthetic data for these columns. Maybe we can add more categorical features if need be. So the first column that I'm passing over here is let's say gender. So this would be np dot random dot choice. I want to pass choice. The choice is either male or female. These are the two different options for the gender column. And what would be the size? The size that I want is number of rows. These are the number of rows that I need. Then the second column would be, let's say, city. So city would be np dot random dot choice. Okay, so maybe I can pass another column that is ordinal. All right, so okay, I'll be adding it. Currently we have only one, which is I guess education. So the city column can takes the values. Let's say it takes Delhi. All right, then I'm passing Mumbai. Then I'm passing, let's say, Kolkata. And next I'm passing over here maybe 4 to 5 cities I can pass, right? Means you can pass n number of cities depending on the requirement, but as far as this example is concerned, currently I'm considering 4 different cities to begin with. So Delhi, Mumbai, Noida, and maybe let's say Chennai. These are the cities that I'm passing, right? Delhi, Mumbai, Kolkata, Noida, Chennai. And then once I have this, then I can mention the size. Size would be number of rows. The size that I'm passing over here is number of rows. So the city is done, then I need to work on education. So for the education, I'll be assigning different values. So np dot random dot choice. All right, and the choice over here is going to be masters. Then let's say grad. All right, graduate, masters, PhD, and high school. All right, so these are the different education categories that we have. And what would be the size? The size would be number of rows. The size would be the number of rows. Then so I've passed gender, city, education, then I'm passing job. So job would be np dot random dot choice. So this would be, let's say, manager, job, or let's say job profile. All right, this is maybe accounts manager. Then over here I'm passing professor. All right, then it could be researcher. Then it could be consultant. All right, so these are the different profiles. These are the different, let's say, choices that I've passed: account manager, professor, researcher, consultant, and maybe sales admin. Then I can pass. So we have accounts manager, then we have professor, researcher, consultant, sales admin, and maybe tech lead. All right, these are the different values that I've passed. So once I have set this, what is the going to be the size? Size would be the number of rows. Size over here is going to be the number of rows. Now I need to pass department as well. Okay, instead of department, I'm going for domain. All right, now, okay, if I need to pass domain, it has to be according to the job. All right, so I'm skipping this domain. Currently, let's proceed with these columns. So we have gender, education, job, and city. Besides this, maybe department or domain could have been categorical, but as of now, let's proceed with this. So df.head, maybe we can add more columns when when it is required. So as you can see in gender, we have male, female. City contains Noida and Noida, Mumbai, Delhi, and Chennai. Education has these 4 categories and job has these categories, right? So the data is generated. Now let's try to understand the first encoding method. And before proceeding this, let's have a look at the shape. Shape is 50,4, indicating what is the number of rows. The number of rows is 50. The number of columns that we have over here is 4. So we do have some clarity on the shape. Then we can also check what are the columns. So these are the columns, right? And if you look at the data types, so df.d types, what are the different data types that we have over here? We have gender, city, gender as object, city as object, education as object, and even job is an object data type. All right, so let's have a look at the different categories and the count that we have. So first of all, हम gender का count देखते हैं. So for gender, if I write the value counts, right? For gender, what would be the value counts? Male is 24 and the female records are, for males it is 26, for females we have 24 records. So because we chose 50 as the size, so this is what we are getting. Next, I can pass maybe city. And for the city, if I write value counts, so these are the different cities that we obtain. So for Noida, it's 12, for Mumbai 12, Chennai 10, Delhi 8, and Kolkata 8. Then if I were to write this, the same code for education, so let's check. So for high school, we have 16 records. For PhD, we have 16 records. For graduate and masters, we have 9 records each. Next, we are left with, after education, we have job. Alright, so if I use job dot value counts. So over here, we have professor, 12 records, tech lead, 11 records, consultant, 9 records, sales admin, 9 records, researcher, 5 records, and accounts manager, 5 records, right? So these are the different jobs, these are the different professions that we have. All right, so considering this data, let's understand the different types of encoding. So the first type of encoding is referred to as label encoding. All right, when it is used, why is it used? Let's understand this. Let's say it is preferably used with I would say target variable as in let's say where we have multiple categories, 2 or more than 2 categories. All right, so that is where we can utilize this. So what it does, it assigns unique integer to each category. All right, it assigns unique integer to each category, typically used with nominal data. All right, now when is label encoding meant to be used? Used when the number of categories, let's say, is number of category ranges maybe between 2 to 15. This is just a rough estimate. There is no fixed, let's say, number mentioned in any sort of documentation, but I'm just writing it, right, for the sake of understanding. Used when the number of categories in the column ranges between maybe 2 to 10 or 12. I can write maybe 10, 12. All right, and the, let's say, the column is significant. These are the scenarios under which we can use it. Now if we were to use library, when implemented through library, all right, the categories are assigned let's say integer values alphabetically. All right, so it works alphabetically. So these are the 4 points. It is preferably used with the target variable where we have 2 or more categories in ML. All right, in ML/DL models. So it assigns unique integer to each category, typically used with nominal data. Nominal data means which has no inherent order. Data with no inherent order. All right, now when it can be used, when the number of categories in the column, in which type of column we are talking about? Categorical columns, right? When the number of categories in the categorical column ranges between from minimum 2 to 10 or 12 and the column is significant. Only when the column is significant we proceed with the encoding. So when implemented through library, now when I'm talking about library, I'm talking about scikit-learn, right, or sklearn. The categories are assigned integer values alphabetically based on the category names. All right, so this is how it is meant to be used. So let's see if I were to maybe apply this. So means the same procedure can be applied using multiple ways, right? So there are ways using which we can assign this. Let's see. So over here, let's apply this on gender. So currently I'll be creating a new column, gender 1, right? All right, so over here we can write for the gender, I'm creating a new column, gender 1, and gender 1 would be df gender dot as type category dot cat dot codes. And then for the gender 1, if I mention the value counts, All right, so as you can see, for gender one, for see 26 was for male. All right, for male it was 26 and for female it is 24. This is the same value that I have obtained over here, right? These are the same values. So this is how we can apply, let's say, label encoding. So it is meant for nominal data. Now when we are creating dummy variables used with, again with nominal data, and let's say it creates binary column for each of the category. It is going to create a binary column for each of the category, right? For each of the categorical column. Typically used, okay, maybe I can copy this point, used when the number of categories in the categorical column has a specified range. All right, so I can copy the fourth point. And this can be implemented using pandas. So this same procedure is called, let's say, one hot encoding as well. So over here, used when the number of categories in the categorical column ranges between maybe, let's say for 2 and 3, we can go for label encoding for 3 and above. All right, maybe from 3 to, let's say, 10, 12. And the column is significant. This is when we can use it. So instead of, let's say, having just one column for each of the categorical columns, we'll be creating multiple binary columns. All right, I'll give you an example to explain its, let's say, sense. For instance, if we have a product column, right? So we have, let's say, product A, B, then we have C, then A, and then maybe we have C again, and then B. So if I were to use label encoding, so this would become 0, then 1. All right, 0, this would be 2, then again 0, then 2, and then 1. But if I were to generate, let's say, dummy variable, so this would be product A, product B, and product C, maybe with an underscore, and for each rows we'll have 0, 1, and 2. All right, so for each row we'll only have 0 or 1. So all three values would be 0 except for product A. Why? Because the original product is A. Likewise, over here we'll have this kind of a data. All right, again for A, maybe I can copy this. This is for A, right? All right, and for C, maybe we'll have 0, 0, 1. This is what the encoding will look like for C. Then this is for A. Then again for C, we'll have 0, 0, 1. And lastly for B, we'll have 0, 1, 0. So this is referred to as the product ABC, the 3 columns that we have created, right? This is referred to as dummy variables. So, or we can call it one hot encoding. All right, these are dummy variables, or we can call them one hot encoding. So this is how we can write them. So let's apply this to check. So what are columns? Let's look at the columns to encode. So what are the columns that I need to encode? I need to encode, let's say, gender is already done. All right, education I'll handle using ordinal encoding. So I need to handle city and job, right? So city and job I'll be handling using this columns to encode. So over here I'll be writing city and then I'll be writing job. Now over here I need to create dummy variables. So pd.getDummies, and in pd.getDummies I need to pass data as df. And what are the columns that I need to encode? So I need to encode columns to encode. All right, over here I need to pass the columns to encode. And once this is done, then I can maybe pass data, let's say d type is integer, so this is d type, and then df dummies dot head. So if you observe this, see, gender is as it is intact, education will handle separately. So gender one is over here. Now how many cities we had? The cities were Noida, Mumbai, Chennai, Delhi, and Kolkata. So for each of these 5 to 6 cities we have a separate column. So we have Chennai, Delhi, Kolkata, Mumbai, Noida. All right, so we have 5 columns for city, and for job again we have 6 categories for job. All right, so this is creating binary columns. Now, can we identify A? Do we need 3 columns to identify A, B, and C, or just 2 would be sufficient? So if I just drop the product A column, this column, so B can be identified as let's say 1 0, C can be identified as 0 1, and likewise A can be identified as 0 0. So we are trying to reduce ML model's performance or complexity by reducing the number of columns if we drop the first one, right, or any one for that instance. So this function provides an argument called drop first that would drop the first column. So over here I can drop the first column as well. So this would be true. Drop first is equal to true. So now city is represented with let's say city Kolkata, Mumbai, Noida. All right, and so city is represented with 4 columns, and likewise job is represented with 5 columns. Next we have ordinal encoding. So let's say used with ordinal data. Ordinal data implying data with some inherent order. All right, so it has some data with inherent order. So let's say based on the order of the categories, they are assigned different integer values. So if we implement it using library, we have to mention the order. All right, so which column can we apply this upon? We can apply this upon education because there is an inherent order, right? So what is the order? This is education. As we can see, the education looks like this, right? So in df dummies, maybe I can use this in df dummies. All right, now in df dummies I can write it like this. So maybe this is education, let's say map. So over here, what are the categories? First of all, it's high school. So for high school I'll be passing 0. All right, then for let's say graduate, I'll be passing 1. For graduate it will be 1. For masters it would be 2, and for PhD it would be 3. So this is what I want to get this replaced. So df dummies maybe education is equal to df dummies education dot replace. Now I can replace it with this education map. Okay, maybe I'm creating a new column so that the original one can be retained as well. So now as you can see, this has been applied. So the numbers would be same, it's just that the meaning is changed. So high school is the, let's say, at the bottom of the hierarchy, then followed by graduate, then masters, then PhD. That is why these numbers are assigned. So high school 0, graduate 1, masters 2, and PhD 3. So now if I look at the values, so guys, as you can see, these are the numbers 16, 16, 9, 9. These were the numbers over here. All right, so we do have the same numbers. So what is 0? 0 is high school. Then what is 1? 1 is graduate. Then 2 is masters, and then we have 3. 3 is PhD, right? So this is how we can apply the different encoding methods. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session we have discussed, we have understood what is the objective, the fundamental purpose of encoding categorical variables, and we have understood and implemented the different encoding methods. In the next session we'll be creating, let's say, data workflows, and we'll be automating some input and output and batch processing files and looped tasks as well. Thank you.